So let's look at some properties of parallelograms. So here I'm given that A, B, C, D, so this figure right here is a parallelogram. They're telling me that. And I want to prove that line segment AB is congruent to line segment CD, and that line segment AD is congruent to line segment BC. So let's figure this out first. If I know that this is a parallelogram, then by the definition of a parallelogram, this line is parallel to this line, and this line segment is parallel to this line segment. And that is just the definition of a parallelogram. If we know that it is a parallelogram, then this pair has to be parallel and this pair has to be parallel. So we can say that AB is parallel, remember these two lines together mean parallel, to DC, and I can also say that AD is parallel to BC, and that's by the definition of parallelograms. Parallelograms. All right, what else do I know? Well, here I have parallel lines, and I have a transversal cutting through them. So what can I say? Well, let's see. Angle ABD, so let me get a different color here for you. Angle ABD, so this angle right here has to be congruent to angle CDB, this angle right here. And I can say that because they are alternate interior angles. I know this because I have two pairs of parallel lines with a transversal cutting through them. So here I have angle ABD is congruent to angle CDB by alternate, interior angles. My pen's not cooperating with me, but you'll get the idea. And let's see, what else do I know? I can also say that angle CBD, so this angle right here, is congruent to angle ADB, also by alternate interior angles. So angle CBD is congruent to angle ADB by alternate interior angles. All right, what else do we know? Well, I can prove that these lines are congruent if, or these line segments are congruent if I can prove that this triangle right here is congruent to this triangle right here. And right now for each of the triangles, I have an angle and an angle. Do I know anything about any of the sides? Well, sure, I know that this side is congruent to itself. So I can say that line segment DB is congruent to line segment DB by the reflexive property. Well, now I have an angle, a side, and an angle. An angle, a side, and an angle. So we've just proved that these two triangles that make up this parallelogram are congruent, and that can help me. So now I can say that triangle ABD is congruent to triangle CDB DB by side angle side congruence. Well, now that I know that the two triangles are congruent, I can say that their corresponding parts are congruent because I know that corresponding parts of congruent triangles are congruent. So we just proved that opposite sides of a parallelogram are congruent. So in any problem that you do further, you know that this side is going to be congruent to this side, and that this side will be congruent to this side. We've just proved that with this proof, so we can use that from now on. No need to prove it again. So now let's look at another parallelogram. In this parallelogram, well, first of all, they tell me it is a parallelogram. So here I have parallelogram ABCD is in fact a parallelogram. So that means that this angle or this side or this, let me try that again. This line segment is parallel to this line segment, and this line segment is parallel to this line segment. That's what we know because it's a parallelogram. So that's given. Well, what did we just learn in the last one? We learned that opposite sides are congruent. So I also know that this side is congruent to this side, and this side is congruent to this side. So I'm going to go ahead and state that. So I can say that line segment AB is congruent to line segment DC, and that line segment AD is congruent to line segment BC. Because in our last proof, we learned that opposite sides of a parallelogram are congruent. So now I have a couple different triangles, right? I have triangle, if I draw them off to the side, it might help. Ooh, that's a terrible triangle. So this is A, B, C, and that goes with triangle A, C, D. But then we also have triangle A or DAB with triangle DBC. So I have these two triangles and these two triangles. And if it helps you to draw them separately, please feel free to do so. I'm trying to prove that our opposite angles are congruent to each other. So again, I know I'm going to have to use corresponding parts of congruent triangles are congruent. So I'm going to need to prove that each set of triangles are congruent to each other. Well, in both of these right now, I know well, I have another set of triangles too, don't I? I have triangle AB in this middle and triangle DC in this middle. So we have lots of different triangles that we can work with to figure this out. The next thing that I see when I do this is that AC, this line right here, is going to be congruent to itself, and DB is going to be congruent to itself, and that's by the reflexive property. So if I'm looking here, this line is congruent to this line because they're the same, and this line is congruent to this line because they're the same, and that's based on the reflexive property. Well, now I have side, 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 don't I? A, B, C, right? This triangle right here, if I make this 3 congruency marks so we can see it better, AB has 2 and BC has 1. And then over here, AD has 1, this one has 3, and this one has 2. So we have a side, and a side. So that works. If we make this 4, AB has 2 and AD has 1. BC has 1 and DC has 2. So again, we have a side, and a side. So we've just proven that these two triangles are congruent by side, 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 and these two triangles are congruent by side, side, side. Now that I've proven that the triangles are congruent, now I can say what they've asked me to prove. I know that angle B is going to be congruent to angle C because they're corresponding parts of the same triangle. I also know that angle A is going to be congruent to angle C because they're corresponding parts of the same triangle. So now we can say that angle B is congruent to angle D and angle A is congruent to angle C because we know that corresponding parts of congruent triangles are congruent. We've just proven that opposite angles of a parallelogram are congruent. So this angle is opposite of this angle, and they will always be congruent. This angle is opposite of this angle, and they will always be congruent. So from now on, we can always use that rule. So opposite sides or opposite angles of a parallelogram are congruent. So in these first two examples, we've learned that the opposite sides are congruent and the opposite angles are congruent. Let's see what else we can learn. All right, so here we have this quadrilateral, and the first statement that they tell me is that this quadrilateral is a parallelogram, so that's good. So what do I know? I know that opposite sides of a parallelogram are congruent because we proved that in our first proof. So I can say that, is this working? AB is parallel, or not parallel, sorry, is congruent to DC. And I know that AB is parallel to DC. And that's the definition of a parallelogram. These sides are going to be parallel and these sides are going to be parallel. Now I can say that angle ABD, so this angle right here, is congruent to CDB, this angle right here, because they're alternate interior angles. I have a pair of parallel lines with a transversal that's running through them. We've proved earlier that alternate interior angles are congruent. With that being said, we've also shown that vertical angles are congruent, and I have a set of vertical angles right here. So angle APB is congruent with angle CPD by the vertical angles theorem. So here I have an angle, and a side. An angle, and a side. So I've just proven that triangle APB is congruent to triangle CPD by angle, side congruence. Well, if I know that those two triangles are congruent, then I can say that their corresponding parts are congruent. So angle line segment AP is congruent, let's use 2, to PC, and that DP is congruent to PB. And we know that because corresponding parts of congruent triangles are congruent. What we have just proven is that diagonals of parallelograms bisect each other. So when you have diagonals in your parallelogram, it's cutting this angle in half and this angle in half, but also it's cutting each other in half. So we're also saying here that this piece will always be congruent to this piece and this piece will always be congruent to this piece. So that these diagonals are bisecting each other, so each side will be congruent to itself.